Amazing people. What I'm going to do today is I'm going to show you how to prove and apply similar triangles. Now, one key thing here is if two triangles are similar, their corresponding angles will be equal and their corresponding sides will be proportionately equal as well. So that's shown by the scale factor. Now, in order to prove that you do have similar triangles, there's a couple of ways of doing about this, and there's some tests that we can use to show similarity. This example here, we'll examine how the proportionality of sides is equal. Now, for this to occur, what we need to do is we need to show that there is a common scale factor amongst all the sides. So the way we can do about this is, remember, by doing the new image over the original image. So in this case here, what we want to do is we want to focus on DE over the corresponding side, which is going to be AB. We want to show that that's then going to be equal to DF over AC, and is also equal to EF over BC. So if we do this by substituting in the numbers now, what we end up with is we can end up with 2 over 6, which is equal to 4 over 12, and that's going to be equal to 3 over 9. And in every single case here, this is going to give us what the scale factor is. And the scale factor in this case, we will see, is 1 over 3. So because of this, we've been able to show that these are similar triangles because they have this similar proportionality of a scale factor of a third. So the second test now, which is showing that two sides and included angle are in proportion. So what we're going to do is we're going to look at the two sides, make sure they have proportionality, so the same scale factor. Then in addition to that, the included angle between those two sides, we need to check is equal as well. So in this case here, let's check the proportionality first. So what we're going to do is we're going to put DE over AB, and we want to make sure that that's going to be equal to DF over AC. And so as we do this substitution, we're going to have 16 over 8, and that's going to be equal to 20 over 10. And in each case, we get the scale factor, which is equal to 2. So we've been able to show that proportionality here. Now, the other aspect we need to show is just that the angle is equal. So we're just making a statement, angle BAC equals angle EDF, and it's just angles are equal. And so from this, we've been able to show proportionality in this instance and the similarity of these triangles. Now, for the third test, what we need to show is that two angles of a triangle are equal. So in order to do this, it's just making statements that we do have equal angles here. So this can be made by saying angle BAC is equal to angle EDF. There is another angle, which is ABC, and this is equal to angle DEF. Now, we only need two angles here. Now, in this triangle, we can prove the third as well. And so that would be angle BCA is equal to angle EFD. Now, this last one was not necessary as part of this. Now, the reason being for that is we only require two angles. The reason being is that the third will logically follow anyway, particularly if you've got those two angles correct, because all the angles in a triangle must add up to 180. So if two of those angles are equal, then the third just must naturally follow as well. So that's why you only need two angles to prove it. But in this case, it was quite clear that you still also had the third angle, but it's not always necessary. Now, the fourth test here is that you need to show that you have the hypotenuse and another side are in proportion. Now, the idea of having the hypotenuse here is actually a dual-edged system in a way. The reason being for that is if you've got an hypotenuse, it means you've got a right angle opposite that as well. So it's also about stating that you have the right angle as well. So in doing this, first of all, let's focus on the hypotenuse. So in that case here, what we've got is we're going to have DE over AC, and we want to show that that's equal to EF over BC because we're showing that proportionality. So this is going to be 18 over 12. And we want to show that that's equal to 12 over 8. And when we do that, we get the scale factor, which in this instance is 1.5. So we do have that proportionality here. Now, in addition to this, like I said, you naturally do have the other thing as well. Because you're dealing with a hypotenuse, that means you've got angle ABC, which is the hypotenuse on the one on the left, with angle DFE, which is the right angle on the triangle on the right. And so this is just saying that you've got the right angles. So it's an obvious part of this solution as well.